All right, welcome back to our fourth and final video on ParkingLot. In part one, we made the parking space object. Here is kind of the public interface for that. It's a constructor and a bunch of accessors and mutators. Even though this method says is occupied and this one says is accessible, that naming convention comes from the fact that it's returning a boolean, right? They're ultimately just getters. They're ultimately just accessors. We've been working on the actual parking lot class. We did the constructor in part 2. That was pretty intensive. We did the toString in part 3. That was pretty intensive. Our focus today is going to be on these 4 methods, which is where I think your focus should be. Right? This is where the big takeaways are at. This is what I'm really expecting you to be able to do. This would be a video where that after you get a method header and some Java doc going, I would attempt these on my own if I were you. I would pause the video and try these out. The first one we're going to take a look at is this occupy. Right? Occupy, we're effectively going to take in a label, a string, and then we're going to set it to occupy. Now this is returning a Boolean value. It could just return void, but one of the things we're going to see over the progression of this class is that returning void, you don't really gain anything. You actually kind of like lose functionality. By returning a value, right, this particular occupy method, it's going to say it's something along the lines of like if it's true or, right, we're going to get true or false value out of this. We're going to say true, we successfully occupied the space, or false, we did not successfully occupy a space. Why could we fail to occupy a space? Well, you could, like if the space is already occupied, that's kind of whatever to me. The big thing is going to be you pass in a label, and that label doesn't even exist. There's no parking space that has that, right? So instead of returning void, I'm returning something. And whenever you actually go to use this method, it's up to you if you want to do something with this Boolean or not, right? We could just do nothing. If we do nothing with this Boolean, whenever we use the occupy method, that's the exact same thing as it being void, right? But if we were to do something, we're actually gaining some functionality there. Let's write this occupy method. So I'm going to flip back to IntelliJ. You see we have our sweet toString, but I'm going to flip over to ParkingLot and I'm going to plug in this occupy method. It doesn't matter where it goes. Usually I like my constructor to be the first thing after my instance variables, and I like my toString to be my literal last thing. So I'm going to squeeze it in between those. I'm going to take this signature and turn it into a method header. We're going to go public. It's not underlined, so no static. None of these things are static. We're at our return type, which is going to be a Boolean. The name of the method is occupy, and this takes in a string, and I'm going to call that target. It's the parking spot that I'm looking for. It's the label that I'm looking for. Let me pull up my Java doc that I want to say, and we'll type that out. I'm going to do /***. This occupy method sets the target parking space to occupied and returns true. Returns true. I don't want the comma there. If it exists. Returns false otherwise. What do I mean? Well, I'm going to try to occupy a parking space, something like B07. Right? So what I'm going to pass into this is a string, the string B07. Now, because it's a string, you could pass in anything. You could say MoonPie. Okay, well there's no parking spaces labeled MoonPie. That wouldn't work. And so that's when we would return a false value. So we're going to set the target parking space to occupied and return true if it exists, return false otherwise. Ultimately, we're going to return true if target exists, and lot false otherwise. Notice I'm not even dealing with the, well, what if the spot's already occupied type of thing. You could, it's just not a big deal. But this is a good spot where I would pause and see if you can tackle this method. I'm going to knock it out. I'm going to show you a for loop solution first, because I know my students love for loops, and I'm going to show you the for each, and hopefully we'll get you to start to transition to a for each loop. But I'm going to plug in my for I shortcut syntax. It's waiting on a condition, so I'm going to tab to that. We'll start at 0, and we'll keep going as long as I is less than the length of my array. The array in this case is lot. So as long as I is less than lot.length. With each iteration, I'm going to pull out the current parking space. Right? We're looping through the array. So I'm going to try to access an element from lot. Lot is a parking space array. Lot at I, what I have highlighted, is a parking space, meaning I can call any of the parking space methods that we came up with on this. What I really want to do is get the label out of the parking space, right? I've got the current parking space, but what I ultimately need to do is compare string to string. So I need to pull the label out of it, and we'll do so with that. This is a parking space array. This is a parking space. This is a string. I want to know, does that string equal the one that I'm looking for? So we'll stuff that into an if statement. I know it's a lot, but this is a parking space array. This is a parking space. This is a string. What I want to know is, does that string equal the string that I'm looking for? If so, I have found a parking space that matches this target. So I want to occupy it. I'm going to take that space, which is lot at I, and set occupied to true. If it's already occupied, not a big deal. Okay. Once we do that, we need to also return a true value because we were successful. Keep in mind, I'm not setting this to void. I'm ultimately returning something. If this was a void method, you basically would be done. But as I explained, we get more functionality. I found a parking space. I set it to occupied. We were successful. Let's return true. If I manage to go through the entire array and I never find a spot with this target, then we can return false. Let's try that out. I'm going to flip over to my driver. All right, we've created a parking spot, a parking lot. I'm going to narrow this back down some so that we don't have so much text on the screen. But we can see our parking lot in its initial state. I'm going to take that parking lot, that is my lot, and I want to occupy a spot. Let's say BO3. So I'm going to pass in a string BO3. I then want to print off my parking lot again to see that change. And there it is. Right? What we're doing with the occupy is that we're looping through our parking space array. We find the spot, we set it to true. Later on, whenever I do my lot, right? Keep in mind what I'm actually doing is my lot.toString. We're going to call the toString method, which loops through and sees, is that spot occupied or not? Well, in this case, BO3 got changed to being occupied because I told it to occupy that. Right? Since this actually returns something, I could print this off. Right? This is a successful occupy. So what I'm going to see out of that is a true value. We were successful. But let's try occupying H03, which doesn't exist. Not in this parking lot. I'm going to try doing that again. Notice we get a false value back. We were not successful in occupying that spot because it doesn't exist. And you see there's no change ultimately to my parking lot. I'll give you a snapshot of the occupy method. And then we're going to check out the next one. Capacity. Okay. Oh, sorry. Before I move on. Yes, I wanted to show the for each loop. Right? This syntax starts getting a little bit messy. I think it's good at first, right? Because I have the opportunity to be like, this is the array, this is the parking space, this is a string, that sort of thing, and kind of break it down. But this is just messy syntax. Okay, let me scrap this. I'm going to show you the for each loop approach. Ultimately, what I'm looping through is lot. Each individual element is a parking space. So I'm going to say for each parking space, which I'm going to refer to as just simply space, in lot. Already the syntax looks a little bit cleaner. It may be a little bit confusing, but we're saying for each parking space, which we will refer to as space, in lot. Right? This is the array that I'm looping through. Each individual thing is a parking space object. Okay, what I want to do is get the label out and compare it to target. So instead of doing lot at I already have the current element. The current element for this iteration is simply space. So space is a parking space object. It's the current one. I'm going to take space. I'm going to get the label. Notice, look at the methods that I can call. Right? These are all parking space methods. That's one way I can tell that space is a parking space. So I'm going to take that parking space, pull out the label, right? This is a parking space. This is a string. I want to know, does that string equal my target? If this is true, I have found the parking space, so I want to take my current space, set it to occupied, and return true. If I manage to go through the entire array yet again, and I never find a label that equals my target label, we will return false. I'm going to run it again, and we'll see that we're getting the exact same value, a false here. And if I switch this back to a B03, you're going to see that we're going to occupy successfully spot B03 and get our true value. So this is our for each loop syntax. It's a little bit cleaner, and I find it to be a little bit more useful whenever we start talking about objects. So for instance, right, one of the problems with our for loop is that we couldn't change the values. Here, I'm not using the array syntax to kind of go through I'm not changing what's in the array. I'm changing the object itself. I'm telling the object, the parking space, to change itself. That's different than changing what is in the array, right? I'm not taking the parking space that's there out and replacing it with something else. I'm leaving the parking space that's there, and I'm telling it to modify itself. That's the difference. So that's kind of that issue with you can't use for each loops to modify the array. You don't really have that per se with our objects. Now, string is a little bit different because strings are immutable. You can't change strings. But in the case of this object, parking space is mutable, right? That is, it has mutator methods. Set occupied is a mutator method. So I'm telling this object to modify itself. So that works. So once you kind of get past that, this idea that for each loops can't be used to modify the array, and you recognize that the objects are modifying themselves, then you can start to kind of appreciate the for each loop for its cleaner syntax. To me, this is sleek, right? Instead of saying lot at I, which is a lot of text, it's not very pretty, this is a little bit more concise to me. Back to our capacity method. I want to take this signature and turn it into a method header. Doesn't matter where it goes. I'm going to put it after my occupy, but we got public double capacity, and we don't need to take in any parameters. Let's see what capacity does. We are going to return the percentage of occupied parking spaces. Okay, I've considered, what if we do accessible? What if we do non-accessible? What if we do all? I'm just going to do all because I really just want to illustrate the idea, not overcomplicate it too much. We're going to play with the accessible versus non-accessible in a later method. Okay, so here's what I want to do. I need to loop through my array, figure out if the spot is occupied. If it is, I'm going to count it. At the very end, I just take the number of occupied spots and divide it by the total number of spaces. So what I need is some type of count. I'm going to create this counter variable called occupied to keep track of the number of occupied spaces. And I'm going to make it an integer because you can't have a fraction of a space, right? Like a space can't be partially occupied. That's my logic. I'm going to loop through and I'm going to go straight to the for each loop. I'm going to say for each parking space, which I'm going to call space in our lot. Okay, with each iteration, I need to figure out, is the current space occupied? So is space, oh, not accessible, is it occupied? If it is occupied, I need to count it. So I'm going to do an occupied plus plus. And after our loop is over, I've checked every space to see if it's occupied or not. I'm ready to do math. You could use a variable here, but I'm just going to do the math at the point of return. I'm going to take my total number of occupied spaces divided by my total number of spaces. Total number of spaces, we talked about this in part 3 of our video. It's effectively the length of my lot. Let's try this out. There's some yellow text. Some of you may have already caught on to it. We're going to have issues here. That's okay. I'm going to get rid of this SOP and go straight back to occupying. Let's occupy a few spots. C4. And how about like DO5? Why don't we also narrow this down to, no, I don't want to change that because I'm using very specific labels here. So we're going to occupy those 3 spots. I didn't really mean to go through a diagonal, but maybe what I want to know is, what is my capacity? I'm going to take my lot and just simply ask for capacity. No parameters for this one, no arguments. That's going to return back as a percentage how many spots are occupied. 0 definitely ain't it. Right, I got 3 out of 20. If I flip back here, that's what this yellow was about. Occupied divided by lot.length, integer division, and floating point context. Integer division. What's happening here? I've got occupied, which is an integer. I've got lot.length, which is an integer. It's the number of elements that is in my parking lot, my parking space array. I need one of these things to be a double to prevent the truncation from happening. Okay, lots of finicky ways that you could do this. Honestly, the easiest thing to do, let's just make occupied a double. 15%, that looks a lot better. And you could change it, like you could move the decimal. Up to you, taster's choice. Let's look at our next method. Accessible available turns a boolean. We're going to go public boolean accessible available. As you might imagine, what we're going to do is loop through and determine if we have an accessible spot available and just simply return a true or false value. So return true if an accessible parking space is available. False otherwise. I want to loop through my array. I'm going to check each spot and ask, is it accessible? Is it occupied? And then I'm basically just going to check every single one. Let's go. I'm going to loop through, and we're jumping straight to the for each loop. For each parking space, which I'll refer to as space in my lot. With each iteration, I have a space. I want to know, is that space accessible? Okay, it's efficient to do this check first because in practice, I have a lower number of accessible spots. So I want to check to see if it's accessible first, and then I'm not even going to worry about checking to see if it's occupied if it's not an accessible spot. I need to know, is it accessible? And is the space occupied? More importantly, is it not occupied? You could write this as is occupied, gives you back a false value, but IntelliJ is going to highlight it and it's going to tell you that that's the same thing as saying not is occupied. Okay, so the way I'm reading this is if the space is accessible and the space is not occupied. If both those things are true, I have found an accessible space, one that is available, and so I'm just going to simply return true. If we manage to go through the entire lot, the entire parking space array, and we never find a space that's accessible or available, I'm going to return false. That is outside the loop. Let's try it out. Okay, so for this one, right, I kind of want to fill these bad boys up. Why don't we reduce this down to maybe 10 spaces with 2 rows. You'll notice that this B03 goes through. There's no errors here, right? Like my program doesn't error out. These things just return false values, and it's sitting here. That's what I mean by we can return a Boolean. And like if you don't use it, then it's the same thing as if you had a void method. And that's perfectly fine. First of all, what I want to do is let's test it to see if a spot is available. So I'm going to do mylot.accessibleAvailable. We get a true value. Okay, but I need to know it's working. I'm going to fill up like a couple of these. All right, let me show you kind of a big brain way to do this. Ultimately, these are strings. In order to occupy a spot, all I need is strings. I want to occupy a bunch of spots. I want a bunch of strings. I'm going to make a string array. I'm going to call it spots, or like occupy list or something like that. But I'm going to use an initializer list. I want to occupy spot A01, and I want to occupy spot A02. Right? I'm going to just a few of them because I want to still test accessible available. But what I'm going to do, and we'll go ahead and throw in B03 here so I can get rid of these boys. What I'm going to do now is loop through the string array. I'm going to pull out the spot and then tell my parking lot to occupy that for each string, which I'll refer to as, I don't know, S. And I should call this spots, and I should call this spot. That's some adult level decision making right there. For each string, which I'll refer to as spot in spots. Right, so we're going to loop through this thing. The very first iteration is going to be that, and then that, and then that. What I want to do is take my parking lot and tell it to occupy the current spot. And that's it, right? This is kind of a faster way to get spots occupied. So let's see. Here's my initial parking lot. And we see that we're occupying those 3 spots that are there in my string array. Our capacity is 30%. That makes sense. And is there an accessible available? There is. But let's take them all up like heathens. I'm going to add those strings to my spots array. Run it again. And see that these were the accessible spots. Is there one available? No, they're all occupied now. So we get a false value back. That's looking good. Last one. First available. This one takes in a Boolean. Ultimately returns a parking space. So this is interesting, right? We got spots that are occupied. So what this Boolean is going to be, as we're going to see, is do we want an accessible spot or non-accessible spot, right? And you could like clarify that a little bit, right? If this is true, right? If the Boolean that I pass in is true, that means I want an accessible spot. And so let's take out one of these things so that we actually have an accessible available. And so we would kind of go through our parking lot and check to see, is this accessible? Is it available? And then we would ultimately land on this one asking, is it accessible? Is it available? It is available. And we're going to return the parking space, right? The entire object. Let's get this going. First thing I'm going to do is take this signature, turn it into a method header. Public. What I'm returning, this is tricky, what I'm returning is a parking space. That's my data type. Okay. The name of this method is called first available. And we're going to have a boolean indicating, do we want the first available accessible spot or non-accessible? And simply put, if this boolean is true, that means we're looking for an accessible spot. If it's false, we're looking for a non-accessible. We could have it so that false is any of them, accessible or not. I don't think so. Okay. So here we go. Let's Java doc this thing. We have this param accessible, true if the parking space should be accessible, false if the parking space should not be accessible. Return the first parking space that is not occupied based on accessible. Here in this context, I'm referring to the parameter accessible, right? This guy here. And here's part of where it also gets tricky. Null if no available parking spaces are found. A couple of different ways to handle that, right? It's possible that based on accessible, we go through and our parking lot's full. Maybe there's no accessible spots. Maybe there's no non-accessible spots. And so what do you return in that case? You got to return a parking space. But if they're all full, there's no available parking spaces, what do you return? Null is an option. We're going to see that in just a moment. I wouldn't focus on it too much. I like it because it indicates that there's nothing available there. It has the potential of creating null pointer exceptions later on, like if you were going to actually use this program. One option is to kind of create a generic parking spot on the fly. Maybe we create spot A00 and we return it. That would be kind of like just a generic object, and you would just have to note that that means there are none available. I like null in this context because I want the first available parking spot. Null are available. Like to me that says none. None are available. Let's go. This isn't as hard as you think it is. We're going to loop through our lot for each parking space, which I'll refer to as space, in our lot. What I want to know is the spot occupied? So I'm going to take that space and ask, are you occupied? More importantly, just as we saw up here, I want to know, are you not occupied? Right? If this is true, I have found a space that is available. But based on this Boolean, I need to know, is an accessible one or not? If the spot is available and its accessibility matches whatever this is, right? How do I know? Well, we have our space. Here's our methods that we can call. I'm going to take that space and ask, is it accessible? If it is an accessible spot, this will give me true, right? I now need to know, did I want it to be true? I need to know if the accessibility matches the accessibility here, right? If I pass in a true value, that means I'm looking for an accessible spot. If this gives me true, that means the spot is accessible. So if the spot is accessible, if it matches the accessibility that I'm looking for, if it's not occupied, we have found an available space. Okay, so if all of this is true, and I would consider flipping this, right? This is just an efficiency thing. I really don't want to check to see if the spot is occupied, if it's not even, if its criteria doesn't even match what I want to look at. Okay, notice that if space is not accessible, I get a false value. And if I wasn't looking for an accessible space, this would also be false, meaning I get it true. Is the space not accessible? Is that equal to, this works, okay? So if this is true, I've found an available space, I need to return the parking space. I need to return space, the whole object. Keep in mind that space is a parking space. If I manage to go through this whole thing and none of this is true, I'm going to return null, indicating that we are full, we didn't find it. I'm thinking I'm probably going to go back through and do a for loop on this one so we can see the differences there. But let's test it out. I'm going to flip over to my driver. Right? I'm going to do a system.out.println on my lot. First available, and let's go with true. I want an accessible one first. B01, right? We went through the array. We landed on this spot, which is accessible and it is available. So we return the entire parking space. Okay, so what that means is what I have highlighted is a parking space. It's the same thing as, so we're taking that parking space and calling the toString. It'd be the same thing if I made a parking space and tried to print it off. There's a parking space here that I have highlighted, and I'm telling it to print that. We're effectively calling the toString of parking space. Let's say false. Let's say that I want a space that's non-accessible. Okay. The first one should be A03, and you see that's what we ultimately get. All right, let's fill this bad boy up. I'm going to create, I don't know, 5 in a row of 1. So let's do A02, A01, A02, A03. I should have changed that. A04, and lastly A05. I'm going to fill this bad boy up. Okay, I want the first available spot that is not accessible. Null, right? They're all taken. Even if I took out A02, I'm still looking for the first available spot that is non-accessible. Still null, right? I have an available spot, but I was looking for a non-accessible spot, and those are all occupied. So we get back a null value. So this method looks good. We're getting close to being done. What I'm going to do is do this as a for loop. I'm going to plug in my for I syntax. We're ultimately looping through lot. So I'll say as long as lot is less than, as long as I is less than lot.length. With each iteration, I'm going to pull out my current parking space and ask, is the accessibility equal to what I'm looking for? So we're going to go into our array at the current index. Lot is a parking space array. Lot at I is a single parking space. I want to know, is the accessibility of that equal to what I'm looking for? So if this is true, I have found a spot with the accessibility that I'm looking for. I need to also know, is it occupied or not? I'm going to pull out that parking space from my array. I'm going to ask, is it occupied? More importantly, I want to know, is it not occupied? If that's true, I have found a space, so I want to return it. I want to return the current parking space that's inside of the array at the current index. Right? Lot is a parking space array. Lot at I is a single parking space, which is what I need to return. Ultimately, this is just one if statement. I can get rid of these braces, but if I manage to go through the whole thing, I'm going to return null. and that's going to be the same thing. The last thing I just want to show you is the other option that I mentioned, which was returning a generic parking space on the fly, right, instead of null. Depends on your implementation. Depends on how you want to handle it. Some programmers, some software developers are going to require that null never be returned from a thing, because that's just prone to null pointer exceptions, that sort of thing. So this is something called like a null object. Don't worry about it. But right here, I'm going to return a parking space, a generic parking space. One that I'm going to make just right here, a new parking space. We need a label. I'm going to throw in a dummy label. And I need the indicators to tell me if it's accessible, occupied, that sort of thing. So there we have it. And there you see our dummy parking space getting returned. I'm just making it on the spot, right? I'm returning a new parking space. What's interesting about this one is it's just like floating right here, right? There are no variables referencing it. And so it gets returned right here. I print it off, and then it gets garbage collected because there's nothing referencing it. But we're going to stop there. Thank you for hanging in. I'll see you in the next one.